Hey, what's happening, guys? We're going to build a simple little board here that's very useful for testing different types of circuits. It is a Sawtooth Generator, and there are many ways to build it, but we are going to build it using our absolute favorite IC, the NE555. Now, while this is searching, let me just tell you, it's going to be a little bit different how we use the 555 in this sense, because we are not going to be taking the output from pin 3, but we are going to be taking the output from right around the capacitor. I think you'll get a kick out of it when you see how this goes together. So let's place our NE555 right there in the middle. And then we are going to need our VCC, and we are going to need our ground, and we are going to need 2 resistors. We'll get them out of the discrete components library. And we'll put one there. And one there. Uh-oh. Amber alert. I always hate hearing that. Okay. So what we're going to do with it, well, wait, let's get the rest of our stuff out of here also. We're going to need a transistor. In this case, I think we're going to use a 3906. where are we at? Come on. 3906, a PNP style transistor. Yeah, that looks about right. So, let's start off by wiring up our VCC and our ground, and we also need to run pin 4, our reset pin, up to VCC. So we'll just pop that in there like that. That looks good so far, right? Alright. Then we need to run our resistor voltage divider here. A little something like this. And a little something like this. Alright, let's put some values in here. We're going to go with 27K on top and 120K on the bottom. Let's get those guys in there. Then we'll connect them together like a so. And then we'll connect the base of our transistor like a so. And we need one more resistor. Now, this particular resistor is the resistor that we will use to set the frequency here. I'm going to drag this guy down like this. I'm going to drag him down here about right about there. I'm just making room here, don't worry. Oops. Yep, we'll go like that. And this one is going to be, let's go with 68K. And it goes up in here like a so. And then this goes down to ground, like a so. And then we're going to connect pin 6 right there, pin 2 right there, and pin 7 is also going to go over to there, just like that. Pin 5 will not be connected. Boom, boom, and then we need a capacitor. So let's put in our cap. What'd you do? Whoa. There we go. Cap goes in here like so, but we'll have to fix that. 1 second, please. Okay, that's better. Now let's just do a little bit of cleanup here. Make sure everything is labeled nicely and neatly, so we know what we're doing here. Okay, good. And then we need the final component. And this is what makes it fun. Oh man, that's a surface mount. I don't want a surface mount. I need a through hole. Give me a second. Okay, we'll just switch over and use an LM358. Oh, pardon me while I move the microphone. Sorry about that. Okay, LM358, right, okay. So we will stike it over here. Something like that. And what we're going to do is we're just going to make a buffer. Just something like this. Nothing spectacular. And the reason we're doing that is because where we're trying to take that wave off of right here is going to be super high impedance. So this will make it work out a little bit better. Drag our ground down there. A little bit of this. A little bit of not connected. Not connected. Come on, up. Okay. I think we're all right here. All right, let's mark these up so we know what we're working with. We'll put the name here, and we'll put the name here. And then we also need come off of here. It's not going to let me. Bugger. Pins. We need a test point. Of course, none of this is going to have a Hey caramba, 1 moment. I know, we'll just grab a connector here, that's all. Connector headers. I don't want a board edge. There we go. Boom, boom. Bring that over here like that. You see that again. Just got to make sure I got the right pins going to the right place. So one is ground. Alright, alright, alright. Move that guy right about there. And then we'll connect our output here, like so. And then this guy comes down here, like so. I think we got everything lined up properly. Oh, we need another one of these for power. So we'll put one of them, and we'll just stick it up here. And this one will be called power. There we go. And this one will be called output. Always best to label these things up as best as you can. Alright, so one is our ground. Like that. That comes up here to there. Okay, let's label our nets here real quick. This is VCC. That one down like that. Properties. This is ground. This is output. Not our, output. Okay. I think we've got it. I don't think I'm missing anything, so let's save this, and we'll call this Sawtooth. And give it a checkaroonie. Pin superimposing. J1P2. No connection. Okay, I see. Come here. Come here. Okay. Make sure we fix that. And we'll verify one more time. All good. Save it. And let's make it into a PCB. Alright, we're now over at our PCB editor. Let's see, we want these to be value, right? Whoopsies. Yeah, why don't you show me value? Alright, there we go. Like to know what I'm working with before I start moving stuff around. Value. gets name. That gets value. That gets name. Okay. So let's start thinking about placing these components. Put our 555 here. Our LM358 there. Capacitor here, maybe I'm thinking, just thinking. Just thinking. Let's maybe try something like this. So I'm moving them around trying to straighten out the rat lines, if you're wondering what's going on. Don't want a whole bunch of these guys. All over the place, so to speak. So like this, like the straighter, we can get them. Kind of the better off everything is. And this is, I don't know, this is more art than science here. Let me try something here. Placement, run auto placement. Let's see what it thinks for auto placement. Whoa! Well, it's a real jumble, but yeah, we're not going to go with that. All right, let's thinkify on this one more time. Let's say, hey, stop that. Let's say we put our 27 here and our 120 here, then our 68 here. I like to line up my resistors. I don't know. Maybe I'm weird. If we try something like this. Are you loving it? So what do we do with this mess here? Oy vey. Nothing's working out symmetrically, and I like symmetry. Maybe like that. Maybe like that. I don't know. I cannot find a happy medium here, so let's just go with that for right now. And let's draw our board outline. Maybe something like that. Oh. Gotta get the right tools there, Polly. Yeah, alright. Let's see what the auto router can do with it. Hey. Looks good to me, right? Alright, let's go to the bottom. And let's run our copper pour here for our ground plane. Maybe a little something like this. Come on. Connectivity. Connect to net ground. Okay, now we're talking. Top. Alright, let's go to our top silk screen. And we'll put our label up here. And electronics. Sawtooth Generator. It's not terrible, is it? Nope. Then I think we need our little friend, right? I don't know where I left him. What, you didn't like that? What has happened? Okay, I guess it didn't like... I don't think you like my bear. Let's save this before something else goes bad. Alright. Let me, Alright, I don't know what quite happened there with the bear. We gotta redo him. So top silk, that's where we want him. Alright, Mr. Bear, where are you at? Good. Alright, we'll save it. Then we'll have a look. I hate that it makes me do this all the time. I know I can turn it off, but then you might be missing components. I don't want that. So, we just go through it. No big deal, right? Right. Glad I asked. Alright, let's see what we got. Okay, learn electronic Sawtooth Generator. There's our voltage divider. There's our timing. There's our op amp, our 555. There's our PNP transistor, our capacitor, our power header, and our output header. I think it looks pretty good. What if we change our solder mask? Let's make a... How about a blue solder mask? A blue solder mask. Yeah. I think I like that. Alright, let's save. And then we will output. 1 second. Alright, so one last check. Make sure there's no problems. And I think we're good to go. So let's export our Gerbers. We shall export them all. They are going to go into Sawtooth Gerber. 2, 5, 6, 7, 8. 10, 11, 12, 13. Alright. And then we also need to export our drill file. And I think we are done here. All we have to do now is order our boards. Alright. So, what do we want? Standard PCB. Single pieces, different design, one each. Where do I upload my Gerber? One moment. Okay. So 45.72, we'll just call it 46. 30.48, we'll call it 31. It is a 2-layer board. You get 5 of them. FR4. Thickness standard 1.6. Go 6.6 on the track spacing. 0.3 hole size. We want blue solder mask. We want white silk screen. We don't need any gold fingers. Hassle with lead. Good there. Via process, we definitely want our vias tented. We'll go over that in a later video. We don't want any more than 1 ounce of copper. We don't need stencils, we don't need assembly. Alright. We'll calculate. $5, and with shipping it will be $22. We shall add that to our cart and upload our Gerber files. So we shall add our Gerber from the desktop Sawtooth Gerbers. Shall submit our order. I think that's it. Now we wait, and for you it'll be a blink of an eye. For me, it'll be about a week. But when I come back, we'll have our boards. Alright? See you when we get back. Well, 1 week has passed, and we got a new knife, and we got some new lights, and no more kidney stones. So we'll see what we got going on good in here, right? There's our boards. Sawtooth. Let's see what we got. Trying to work my way into here. Hey, they look pretty good. Yes, indeed. Let's take a close-up look. So we've got our logo, looks real nice, and we've got our top silk screen looking good there. We've got our IC labels, the LM358N, the NE555P. We've got labels for our resistors, 27K, 120K, 68K. Power and input headers are labeled. I must have forgot to put a label for that capacitor on there. That's my fault, I'm pretty sure. You can see the traces there, looking good. We got the back side. Real nice. All we got to do now is put it together and see if it works. What do you say we do that? Alright, so we're building. Pick a nice suitable board. Make sure we've got our two ICs. We've got our capacitor. Where are the resistors? Where are the resistors? I know they're around here somewhere. Okay, there's a 27K. I think that's maybe that's another 27K. Better check it. More playing around with this meter, and I'm tending to not like the screen so much. You're going to see here in a second. It's just not all that bright. See, we got direct light on it. It's kind of hard to see. Now, in indirect light, it's just fine. Now my little mini grabbers don't want to grab, they keep popping off because, you know, something's got to go wrong. That's just the way the universe works. Murphy's Law, right? Something can go wrong, it will go wrong. You're all familiar with Murphy's Law. How about Cole's Law? Are you familiar with that? It's mostly just cabbage. Wah, wah, wah. Stupid joke. Alright, let's check the other resistor. Now it calls for 120K, but I don't have a 120K resistor. So we're going to make do with 100. And it's going to throw off my calculations a little bit. But we'll make do. Man, I tell you what. I picked way too small holes when I laid this board out. So it's not exactly cooperating. Have to use a little gentle persuasion to get everything to fit in there just about right. You know what I'm saying? Alright, and this is the final resistor, the 68K. It's a real skinny one. It fits no problem. And the capacitor. Alright. Now we can solder these babies in here. I'm using that, what's it called? KSGER, the T12 type soldering iron. It seems to work pretty good. I like the feel of it. It's got a really nice flexible cable. Had it for a few months now, and I've been using it primarily, so all seems relatively good. Get these guys soldered on here. Trim off the leads. Move on to the next section. Now you see in the lower left corner there, that's the power and the output jacks. I did not do them on 0.1 inch headers. Again, my bad. So we're going to have to improvise, adapt, and overcome. No problem there at all. Let's get the transistor in. This is the 3906. It is a PNP transistor with the emitter going to the positive rail. Again with the small holes. You'd think I had the eyesight of a 12-year-old Swedish boy, not a 50-year-old man. But we'll make it work. Somebody says you should have an output monitor so you can see what you're doing. Yeah, I should, and anybody who wants to buy me one is more than welcome to. You know, we're operating on a shoestring here, boys and girls. We don't really have a budget. Now, I do want to acknowledge the loss of a prominent YouTuber, Grant Thompson, the King of Random. I wasn't a big fan of his channel, but, you know, it was good entertainment, and my condolences go out to his family and friends. That is a horrible loss for anybody to be lost at that age. Alright, now we're soldering up the ICs. You always want to keep your tip clean. Get one soldered in there. Make sure everything fits nice, and then just bam, 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 bam. Right down the board, and we'll solder them all in. Ain't nothing to it but to do it. This overdubbing is weird for me. I'm usually talking as I'm working, but in this case I was listening to some Leonard Skinner, so you know how YouTube frowns upon copyrighted material in a video, so kind of had to make do. Yeah, so I want you fit. Of course, can't get my big old fingers in there, so you have to get some assistance. A little bendy, a little torquey, a little twisty. Everything will go in just fine. Now you can see the ground plane real good on the back of that board there. I like the blue solder mask. That works out really nice. So while we're soldering with an L, just a quick reminder that this video is sponsored by PCB Way. They are a Chinese printed circuit board manufacturing company. And you can get 5 boards for about $22 in about a week, excuse me. Man, I just think back to the days when I was making my own printed circuit boards at home and etching them, and man, global commerce is a great thing. No matter who you're dealing with, the fact that you can get quality products, you know, at a low cost in a week from China. It makes us all inventors, you know. Design your stuff for $22, even if it doesn't work out. You've gained some experience, and you had some fun. Okay, like I said, these headers were definitely too small, so we're going to have to put in wires instead of jumpers, but, you know, no big deal. So why a Sawtooth generator? Well, it's basically a ramp generator, and it allows you to test different circuits. I'm going to use it for some filter circuits for a ham radio project. Be some bandpass filters, and this is going to go right through the range, and I just want to see how those filters react to everything. So black and red for power, another black for the ground on my output. But, you know, because I'm getting old and senile, I'm going to use a different color for the output. Let's go with yellow. Yeller. Oh, yeller. That'll work out, right? Right. There we are. So she's looking pretty good. Let's get it hooked up. See how she works. If I worked out these frequencies right, we should be somewhere around 75 kilohertz. Put up all my grounds. Then my power. Then my lead. Alright, let me move the camera and we'll take a look. Okay, so there we are. Doesn't look right. Hold on. That's better. Just increase the voltage a little bit. So we're looking at 85 kilohertz. Go back down. There we go. So we can sweep it around a little bit with the voltage. 85 kilohertz. Let's look at that. Take a look at that rise time. .6 microseconds. That's pretty good. So I am pretty happy with this. Hope you guys like it. I shared this on the PCB Way site, so you guys could actually get these boards made for yourself if you're interested. There'll be a link down below. If you guys enjoyed the video, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to PCB Way for sponsoring. Big thanks to the patron. Bigger thanks to you. That's it. I'm out. Peace.